This example is about the dead load and live load on the steel beams. So a composite steel beams and reinforced concrete slab. So this is concrete slab, this is steel beams. Floor system consists of three 530 UB92. So there is a one universal beam, second universal beam, third universal beam spanning 8 meters. So the span of the steel beam is 8 meters, supporting 150 millimeter thick slab. So this is the 150 millimeter slabs. Built on the slab is 350 millimeter thick load bearing clay brick wall. So there is load bearing clay that support two concentric loads. So there is something coming on top of this, well, for example roof or something that is pointing the two concentric load, whose service magnitude are dead load is 10 kilonewton and the live load is 20 kilonewton. So this P has two value, one for the dead load is 10 kilonewtons and another one is 20 kilonewton. Slab on the left facing of the side of the brick wall is to be used for office. So if you are taking the left side of this one, so it would be office, and other side of this one used as a bedroom for the apartment. So one side on the office, another side of the bedroom. Regardless which one you take, it is no problem because both sides are 400 millimeters. Allow 0.5 kilopascals on the slab on both sides of the wall for the permanent attachment like ceiling, lighting, floor covering, etc. So on these slabs we have a 0.5 kilopascal dead load, for example carpet or some other fittings that are applied onto the slab, so that will apply 0.5 kilopascal dead load. Construct the line diagram of the central UB showing. So we need to draw the line diagram UDL load on this universal beam, how much dead load and live load applied on due to this load bearing wall and slab. Service load, which is the dead load, service live load, which is the live load of the wall and both partition of the slab fully loaded, and the service live load with the wall and only office side of the slab loaded. Calculate the maximum design ultimate shear force and bending moment for this beam. So we can show these examples in the various sections. First we will try to work out the dead loads of the on these examples. Now for the dead load, we can first find the UDL line load on the slab due to the concentric load of P and P. So I just try to draw this wall here, that is a wall here, and this P concentric load will try to create the UDL load along this line. So that is UDL load is 2P because there are two force 2P, so there are 2P over 10. Now that force is kilonewton. 10 meter is this one. This is the 10 meters that I divided by. So this 2P, 1P, 2P divided by 10. So that much kilonewton per meters. Now the first question is to calculate the dead load on the steel beams. What we are trying to do, how much dead load applied onto the steel beams due to the self weight of the steel beams, due to the weight of this slab, due to the weight of these brick walls, and also the dead load coming from this P. Now first of all, from table A2, page number 21 on AS NZS 1170.1, table A2 on AS NZS 1170.1 2002. It has in the wall sections, if you go to the brick masonry, burnt clay per 10 millimeter thickness. So if you have 10 millimeters of thickness, it has a 0.19. The unit is kilonewton per meter square. So the weight of brick wall of 10 millimeter thickness is 0.19. So therefore weight of the brick wall is 0.19 kilonewton per meter cube, and that is for 10 millimeter thickness, and that is given in table number A2, page 21 on AS NZS 1170.1. Now the thickness of the brick wall is 350 millimeters, as I can show it here. The thickness of the brick wall is 350 millimeters. Now we need to convert. We know the value for 10 millimeters, right? So if I like to convert it for 350 millimeters, so we need to multiply this one. We need to multiply this 350 millimeters times 0.19 over 10, so 6.65 kilonewton per meter square. So we are just converted 0.19 into 6.65 by saying that if the wall has a 10 millimeter thickness, it has 0.19 pressures, weight pressures, then we can convert into 350 multiplying with 0.19 over 10, so that gives us 6.60 kilonewton meter. So this is the weight for the case of 350 millimeter thickness. All right, once you have pressures, we need the UDL load in kilonewton per meter. So pressure times perpendicular length, so that is 665 kilonewtons times 6 meters. Now the concept is to select this length. Now here, look at here. Now this wall going to apply the UDL load in these directions, right? For example, if I have this one here, the UDL load going to come here on this beam in these directions, right? So the perpendicular length is 6000. You can see the UDL load going to apply in these fashions on this universal beam. So the perpendicular length is 6 meters. So therefore we are multiplying perpendicular length 6 meters, and if multiplication give 39.9 kilonewton per meters. Now that is the dead load coming onto the steel beams from this brick wall. Now the second case, that UDL load due to the concentric load P and P, like how much this load is coming onto this this wall. So how much this load gonna come onto these steel beams, that is 2P on 10, which is, this is 10 millimeters, 10 meters. So 2P on 10, and 10 kilonewton is given, because if you see on the question, that is for the dead load is 10 kilonewtons. So we substitute this 10 kilonewtons here and divide by 10 meters, that is 10 meters. So that is 2 kilonewton per meter. So that's 2 kilonewton per meters coming on to this steel beam due to this loading. Now total UDL for the dead load G is equal to 2 kilonewton meters that we just calculated, and then 39.9 kilonewtons meters that we just calculated from the brick wall. So that is 41.9 kilonewton per meters. Now these brick walls, please note, these brick walls and these point loads will gonna create the concentric load on the steel beams, not the UDL load, just the point load. So we are interested in calculating the concentric load or point load equal to UDL times length. So 41.9, that is from here, and please note length. Now this is very important here. The length that we're gonna take it is just 5000 or 5 millimeters. So how it gonna work? Because if you take the half here, that is 2.5 meters here, 2.5 meters here. So we are just going to take this length, okay, for this case. Now because this half of this slab will be carried by this one, half portion of this slab will carry by this steel beam, half of this portion will be carried by this one, half of the portion will be carried by this steel beam. So only 5 meters will be carried by this steel beam. So therefore this 5 meters coming from this one, that will give us 209.5 kilonewtons. Now self weight of the slab in kilonewton per meters. Now we are moving, so this is the concentric load. Now self weight of the slab in kilonewton per meters. So we are now moving on to this slab. We finished this concentric load, we finished the brick wall. Now we are working on this slab. Slab will create the UDL load in these directions, like along the length of the beam. So this slab has a density times the perpendicular area. Density is 24.6 kilonewton per meter cube, that I can show it here. Density of the concrete with the reinforced concrete slab is 24, and we need to add 0.6 into it because it's a reinforcement. Without reinforcement is 24, but with the reinforcement is 0.6, that is 24.6 kilonewton per meter cube. So that is 24.6 kilonewton per meter cube times the perpendicular area. Now we need to understand that what is the perpendicular area. Now along this length we are going to create this for example, this slab I draw it here like 10,000 millimeters, that is 10,000 millimeters, and we have a thickness of 150, and the length along this one is 8,000, right? So now this will create the steel beam is under this one. Now these steel beams will subjected to this loading, so we need to create this. We have this 5,000 millimeters or 5 meters of length, because they are coming from here. Now, and this UDL, this slab will create the UDL load, so we need to take this perpendicular area, right? So therefore 0.15 times 5 meters, that will give you the UDL due to the slab. Now once you calculate for the slabs, we need to calculate the dead load on the slab, because in the examples it's saying that the slab also has 0.5 kilopascals dead load. So on this slab it has a weight, but on top of this weight you have another dead load coming onto the slab, which is 0.5 kilopascals given in the question. So we have 0.5 kilopascals pressure coming on this one. We need to convert pressure into UDL load. So UDL is equal to pressure times perpendicular length. That perpendicular length at 5 meters that we just saw it. So 0.5 kilopascals times 5 meters, which is 2.5. We are not taking 8. Please note, we are not taking 8 meters because this is parallel length. We need the perpendicular length, which is 5 meters. So this is 2.5. Now self weight of the universal beam 530 UB92, because this universal beam also support their own weight. So we need to find the weight of the steel beams, universal beam. Now if I check the one steel tables, which is 530 UB92.4, 530 is stand for this D, depth of the universal beam. 92.4 has a unit of kg per meter, so that's the weight of the beam. 1 meter beam has a 92.4 kilogram. So that is 92.4 kilogram coming from one steel table. And 92.4 times 9.18 converting kg into Newton, and we are interested in kilonewton per meter, so dividing by 1000, so it gives us 0.906 kilonewton per meter. Now total UDL load coming onto the beam is the weight of the slab that we just calculated, which is 18.45 kilonewton per meters. Dead pressure on the slab, so we have 0.5 kilopascal, so that is 2.5 kilonewton per meters. And we just calculate the self weight of the beam is 0.906. So the UDL load coming on to this beam is 21.56. Now if I draw it on the line diagram, because it's asking you to draw a line diagram, this steel beam is let's say along this line. We are drawing these steel beams here like this along this line, so that is 8 meters. And on these steel beams, due to this slab and self weight of the steel beams, it will create this rate UDL load 21.86 that we just calculated, 21.86. And this brick walls and this load, concentric load, will create this point load, which is 209.5. It's gonna be pointing at the 4 meters. And that we calculated in the previous step, which is 209.5 kilonewtons point load. So that is 209.5 point load. So it's basically self weight of the beam and slab weight, and also the dead load that will have a UDL load 21.86. Brick wall and this concentric load will have a concentric load 209.5 kilonewtons. This is the answer for section A. Thank you very much.